Discussed this process last week, and we've said that this represents the entire life cycle of a data mining project. So let's discover these different phases one by one, starting with business understanding. So before we even open a spreadsheet, we need to understand the why behind the project. This is the business understanding step. It is the first step of the data mining process cycle. And here we're trying to answer questions like, what is the business trying to achieve? What problem are we solving? Who needs the answers? And what decisions will it support? Before we go further, let's introduce the theme we will be using throughout the course, which is retail. Why retail? Because it's familiar to all of us. You've bought things online or in stores, you've seen personalized ads, you've used coupons, and that's really retail data in action. So in this course, we'll try to use a simulated retail data set to explore the different real data mining tasks. We'll try to do things like explore and mine different products that are frequently bought together, or find different customers who are likely to return. We're going to try to detect trends by location or time of the day and so on. So this common theme will help us tie all the different assignments together and gives every concept we learn a practical context. Now let's apply what we've learned about business understanding to our retail case study. Suppose you are working for a large retail chain and the overall business goal might be to increase the sales and keep customers coming back. So from there, we can define a data mining objective like using past purchases to find patterns that help improve marketing or inventory decisions. Some questions we could ask in this stage are, what products are frequently bought together? Are the customers who haven't returned in a while? Are there any customers who haven't returned in a while? Which are they? Do certain items sell better than others? And so on. So these questions will shape the entire data mining process, and we should always start our project with the business goal, and then the data comes second. Now let's explore the data understanding step. This step helps us answer a crucial question, which is, what kind of data are we working with and can we trust this data? We start by collecting the initial data, pulling in whatever sources are relevant, like sales logs, customer records, or inventory scans, and so on. And then from there, we describe the data, things like how many rows and columns do we have, what type of variables, what's the basic shape, and so on. And then next comes the exploration of the data, where we dig into distributions, we create some visualizations, and we begin spotting some patterns in our data. And then finally, we check the overall quality of our data. And this step actually saves us from major headaches later. So it's better to understand data now, and the better we understand our data, the smarter and the safer our modeling stage will be. So data understanding is also called exploratory data analysis, and as we said, it is the process of investigating and understanding data. In this stage, we will be using two main techniques. The first is descriptive statistics, and the second is data visualization. So let's be honest, it's tempting to just jump right into building models and generating predictions, but the truth is, if we don't understand the data first, everything else you build is actually on a shaky ground. The data understanding phase is what separates good data science from just running code, right? You need to know things, what your data looks like, where it came from, what's missing, and whether it even makes sense. So here, try to imagine cooking a meal without checking the ingredients first, right? So you might end up with the expired milk or salt instead of sugar and so on. So in data mining, we always say garbage in, garbage out. So this step isn't just important, it's actually essential to start with. So the first step in data understanding is obviously collecting the data. So this might seem as just grabbing a file, but it's actually more strategic than that. So we begin by identifying all available data sources that could help us answer our business questions. And that could be databases, spreadsheets, APIs, reports, any source that hold useful information. So in the case of our retail theme, this might include the online transaction logs from the company's website or in-store barcode scanner data or loyalty program records, or even customer support tickets that might give some insights into complaints or returns and so on. So you also need to pay attention to how the data was collected. Was it collected consistently across locations? Is it recent? Were there any known issues with login or tagging? And the goal of this step is to build a working data set that represents the problem space that we're trying to solve. So sometimes you might need to merge different sources. So you need to filter out irrelevant entries or documents that won't add any relevant value to your data. So this step sets the stage for everything else. So if you collect irrelevant data or low quality data, then no analysis could save you later, right? So it's not just about having data, it's about having the right data. So once we've collected the initial data set, our next move is to try to describe the data, right? So this doesn't mean writing a paragraph about it. It actually means to use some summary statistics and basic metadata to get a clear picture of what we're dealing with, right? So you answer questions like how many rows and columns, how many features, what are the feature names, what are the data types, are the features numeric, categorical, and so on. Are there any identifiers like IDs, customer ID, order number, and so on? And one of the first things a data scientist typically does is to run the info function or describe function, both in Python. So this gives a snapshot of the data set shape, the column types, and statistical summaries like the mean, the min, and the standard deviation. So, for example, if we look at the retail data set and see that the purchase amount right here ranges from 0 to 15K, we might already spot something suspicious, right? Also pay attention to how balanced the data is. Do we have data from all the regions, right? Are most purchases from just one store? And then are all the customer ages clustered between 25 to 35? So here you're trying to find some general trends in your data. So it's about profiling the data and getting like a structural overview before diving into deep patterns in your data. So think of it as like reading the table of content of a book before reading the book itself, right? So you're not yet into the analysis, you're just still making the ground towards it. So let's talk about the measures of center. So these help us understand where the middle of our data is. The most common one is the mean or the average. So you add up all the values and divide them by how many there are, and it's easy to calculate and useful. But the problem is it is really sensitive to outliers. For example, if most of the customers spend between 20 to $100, but there is one VIP shopper who just dropped 5K, right? So this will result the mean to get pulled upward, and it doesn't really represent the typical customer anymore, right? That's where the second measure comes in, which is the median. The median is the middle value when you sort the data, so it gives a more accurate picture when the data is skewed or has extreme values, as we've said before. So for instance, in our retail case, if the mean purchase amount is 80, right? If the mean is $80, but the median is 40, right? So this tells us that most purchases are on the lower end, but the average is skewed by a few big spenders, right? So lastly, we have the mode. It is the most frequently occurring value. This is especially helpful with categorical data. Say you're looking at payment methods and the mode is credit card. This tells you that it is the most common. So the mean shows the average, right? The mean shows the average, the center, the median shows the center, and finally the mode shows the most common value. Now that we've talked about the center, let's talk about the spread of the data, right? In other words, how much the data varies. Think of it this way. So two stores might have the same average daily sales, say 5K, right? But one store is very consistent while the other swings wildly from 2 to 9K, right? That's the spread. So the most basic measure is the range, just the difference between the highest and the lowest value. But this measure is sensitive to outliers. A more reliable measure is the standard deviation, right? So it tells you how much the data varies around the mean. So a low standard deviation means most values are close to the average. If we look at this example right here, so this is low standard deviation, and a high one means that the data is all over the place, right? So there is also the interquartile range, IQR. This tells us how spread out the middle 50% of the data is, so between the first and the third quantiles. It's less affected by outliers, so it's a good tool for spotting dense versus scattered data, right? So you can think of the spread or the measure of spread as the personality of your feature. Two data sets may have the same average, but if one is tightly clustered and the other is widely variable, that changes how we interpret and model that type of data, right? So knowing the data will help us make decisions like, do we need to normalize the data? Are there outliers to investigate? And so on. So the center helps you tell where the data is, whereas the spread tells you how much it moves around. So we've looked at where the data is centered and how much it spreads, but now let's talk about the shape or the distribution of the data. So this tells us about the overall pattern of the data when we visualize it as a histogram or density plot. So knowing the shape helps us choose the right analysis technique and avoid false assumptions about the data. So the most well-known shape is the normal distribution. It is symmetrical, a symmetrical bell curve, right, like this. And in a perfect normal distribution, the mean, the median, and the mode are all exactly the same, right? Many statistical methods assume this shape, so it is important to check whether your data follows it or no. But in real world, especially in retail, the data is often not symmetrical. So a right skew distribution has a long tail to the right, right? And that means that most values are low, but there are a few high ones pulling the mean up. Think of customer spending. So most people spend modestly, but a few spend a lot, right? On the other hand, left skew distribution is the opposite. So most values are high, with a few very low ones pulling the mean down. There is also bimodal distribution and other shapes. So the shape matters because it impacts how we interpret the averages and outliers, right? So meaning if you assume that your data is normal but it's actually skewed, you could misinterpret trends or choose the wrong algorithm to analyze and model your data. So always visualize your data using a histogram or a box plot. This can tell you more about the shape of your features. So now that we've described the structure of the data, it's time to explore it, and it is where things get visual and interactive. So the goal here is to develop an intuition of what the data is telling you. We're not building models yet, we're just trying to spot patterns, trends, and surprises or outliers in your data. So start by asking basic questions like, are there any unexpected values? Do relationships between variables seem linear or scattered? Are there any trends across time, location? The best way to answer these questions is using visualizations. So charts like histograms, these help us understand the distribution of numerical features, right? So when we talk about histograms right here, you can use it for things like the purchase amount or age features. And then there is box plots that can help you spot outliers. There's also scatter plots, right? These help you explore relationships like price versus quantity or age versus loyalty status and so on. If you're working with categorical or nominal features, like the payment methods or the product category, you will want to use things like bar charts right here or count plots. So these help you see which category dominate and whether your data is in balance or no, and so on. You can also use pie charts and so on. So using these different charts, you can start spotting potential data quality issues, like if a feature has too many categories or there are any odd gaps or inconsistent labelings and so on. So here you think of it as just getting to know your data before you actually start to clean it. Once you've looked at each feature individually, the next step is to try to explore how they relate to one another. So this is where data starts to get really interesting, because relationships between features can uncover trends and correlations to inform the rest of the analysis. For example, do older customers tend to spend more on average? Do specific payment method correlate with higher purchase amounts, and so on. So for numerical features, we use correlation matrix like a heat map to see how strongly features are related. So a high correlation between two features might mean one is redundant, or it could suggest a useful pattern right there. For categorical features, you can use cross tabulation or grouped bar charts to see how distributions differ across categories. So this step is very crucial before modeling, because it helps you spot predictive relationships and also remove redundant or irrelevant features.